Welcome to Simply H2 Math video series specially made for JC students. I'm Mr. Song from Learning Simplicity. In this series, we shall discuss about
Series. Series is sum of ordered sequence. It can be denoted in the sigma notation form. Example of sigma notation form will be as such. 1 plus 2 plus 3 all the way to n can be written as a sigma notation form from r equals to 1 to n with the variable r. Further to this, it can be represented in 5 basic standard series. The first being sum of constant. Can denote this as summation r equals to 1 to n, a, where a is a constant, the outcome will be n a. For the second one, we have a sum of AP. Summation r is 1 to n, r. The outcome will be basically n over 2, 1 plus n. Take note that this n is actually the number of terms. 1 is the first term, n is the last term. In addition, we also have the sum of GP. I can denote this as summation r equals to 1 to n, a to the power of r. So the outcome of a summation of n terms of a GP is the first term, common ratio to the power of number of terms, minus 1, divided by a minus 1. So this is the first term. This a denotes the common ratio. This n denotes the number of terms. Whereas for this a is actually the common ratio, r. In addition, we have sum of square. Summation r is 1 to n, r square equals to n over 6, n plus 1, 2n plus 1. Finally, we have sum of cube. The summation notation form is denoted by n over 2, 1 plus n, whole thing square. For 4 and 5, the formula given in the question itself. So you do not need to remember the formula. Let's consider example for application of standard series. Let's consider the problem of summation r equals to 1 to n, 2r plus r squared minus 3 to the power r. This summation can be broken up into 3 different parts. From r equals to 1 to n, 2r plus summation r equals to 1 to n, r squared, minus summation of r equals to 1 to n, 3 to the power r. The constant can be taken out to form r equals to 1 to n, r. Summation r equals to 1, n, r squared, minus summation r equals to 1, n, 3 to the power r. Take note that the first summation is that of a AP. So we can basically use the formula. So it's n over 2, 1 plus n. For the second one is a sum of square. So the formula will be n over 6, n plus 1, 2n plus 1. Finally, the last one will be summation of a GP. So the formula will be 3 to the power 1, 3 to the power of n minus 1 over 3 minus 1. Okay, if you further simplify this, you get n, 1 plus n, plus n over 6, n plus 1, 2n plus 1, minus away 3 over 2, 3 to the power n minus 1. If a problem doesn't consist of the standard series, we have to use the method of difference. Then let's consider a sum whereby involve the method of difference for two terms. Consider summation r is 1 to n, 1 over r minus 1 over r plus 1. I can list out the first two terms as such. 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3. I can also list out the last two terms, which is 1 over n minus 1 minus 1 over n plus 1 over n minus 1 over n plus 1. Cancellation can be done here. At the end of the day, you have the outcome which is 1 minus 1 over n plus 1. What happens if you have three terms? There's a simple way to break up the three terms into two sets of method of difference. Let's consider this example. You know that the middle term can be split up into two different terms as such. With that, I can basically form two methods of difference in the following manner. So for this part here, I can make use of the earlier answer, which is 1 minus 1 over n plus 1. For this part here, I can apply my method of difference. So it's 1 over 3 minus 1 over 2 plus 1 over 4 minus 1 over 3. And these are the last two terms. Last two rows. Again, the same thing, I can carry out cancellation. So finally, the outcome for this will be 1 minus 1 over n plus 1 plus 1 over n plus 2 minus half. So to simplify this, I get the following expression. Finally, we come to the part of convergence of a series. What do you mean by a convergent series? It basically means that the sum to infinity is equal to a constant value as we sum to infinity. So the example that we can take is as such. So for example, for summation from 1 to infinity of half to the power of r. Okay, you realize that for this summation for this sum to infinity is basically a sum to infinity of a GP. So for GP itself, the sum to infinity, I can apply the formula of A over 1 minus R. So it means to say, the outcome for this will be half divided by 1 minus half, which is basically equals to 1. This will occur when your common ratio is between minus 1 to 1, and this summation satisfies that.